Alright, so it does look like I have 1 hour left. And if you're wondering why I didn't do it last night, it's because I was making videos for my year 11s. And I took a nap and then woke up early, did the PowerPoints, and then now doing the videos for you guys. So, chain rule, bread and butter, exercise 9E. One more practice on this, the sheets I said in the orientation. So in the previous video on the power rule, I mentioned about in the holiday homework, and I've shown you in the other video, power rule. That one has some sheets for you to practice more chain rule. Again, that was last year's stuff, and if last year you didn't do the questions, do them, okay? And if you've forgotten them, do them, okay? Otherwise, the questions in your textbook will be enough if you got it last year already, okay? So let's jump right into it before I run out of time, okay? So let's go, come on, move. Yeah. Alright, so exercise 9E, chain rule. What is chain rule? You remember what I said last year? I said it is a function within a function. So now that you know composite function, this is actually good, because that means every time you see a composite function, it is a chain rule problem. Okay, so remember a function within a function. So I'll give you another example. So log e of root of x. Yeah, we've done composite function. So this would be saying that f of x is equal to log e of x, and then the inside function, which is g of x, is equal to root of x. This is a chain rule problem because we're going to replace that g of x. We're going to replace that with another letter. Okay, that's the aim. So same thing with this one. This is now, what, 2x squared minus 3 to the power of 5. Now you should be able to pick out when it's a chain rule, because when you have a composite function, it is a chain rule problem. So in this one, I can say f of x is broken up into x to the power 5, and the inside function is g of x, which equals to 2x squared minus 3. Because if you wrote f of g, you would say sub 2x squared minus 3 into x to the power 5, which actually gives you that. Okay, so that's actually, I just realized that actually. How about that? So a composite function, a function within a function, is a chain rule problem. Okay, so what is the rule? The rule is do y. Oh wait, let me just give you. So when you have, when you have a function within a function, so y equals to, how do you write this again? How do you write this again? That's product rule, chain rule. A function within a function, so let's say that f of u, okay? Then dy du, dy dx, sorry. This is tricky. This is tricky to write in simple notation, that is. The chain rule from last year, I said it was this. I said dy dx equals to dy du times du dx. This is your chain rule, okay? And you're wondering, well, what is u? Because x makes sense, but what is u? U is the third variable that you're going to introduce. Why do you introduce a third variable? Because you're replacing the inside function, okay? So if you think about, if you relate it to composite functions, you're replacing it with g of x, okay? You're replacing g of x with a third letter. So for example, again, if I did, I don't know, let's say square root of x squared minus 5x. Yeah, that's a composite function. This is your g of x, yeah? Whereas f of x equals the square root of x. True? Well, the idea is to eliminate the problem. See, what's the problem? If I ask you to find the derivative of x to the square root of x, it's so easy. Derivative of f is so much easier to do, but the derivative of square root of x squared minus 5x is hard. So what you're going to do in the chain rule is you're going to replace this. You're going to replace g of x with a new letter. You're going to call it something else. That's why we introduced the third variable. Okay, so we just make up a variable and we say, all right, what if I chose another letter? What if I then called this u? Oh, what's going on? No, it's lagging. U equals to x squared minus 5x. Why do I do that? Because then now it is the square root of, wow, what the hell happened? Seriously, stop doing this to me. Oh my god. Alright, there we go. Now, when we replace x squared minus 5x, you've got the square root of, instead of x squared minus 5x, you said, let's call it u. See, this in itself is so much easier to work with. You can find the derivative of that. Just like I said before, you can find the derivative of root of x so much easier. If you didn't know, again, this goes back to your basics. Square root of x is the same thing as writing x to the power of half. X to the power of half is square root of x. Okay? And that's why it's easy, because you can just use the power rule, drop it down, minus 1. That's why it's easy. Okay? So, for each one of these problems, I'm going to show you how I do them. So, let's do the one I highlighted before. Let's do this one. Okay, actually I'm going to press back. We're going to touch that later. So if we are going to do this chain rule problem, you got y equals to 2x squared minus 3 to the power of 5, right? So what's the issue? See, if I just gave you x to the power, if this was split up into its composite functions, f of x would have equaled to x to the power of 5. G of x would have been the inside function, which is 2x squared minus 3. You see, you're really just substituting 2x squared minus 3 into that. That's why it's a composite function, right? This is so much easier to derive. This is so much harder to derive. So what we're going to do is we're going to say this. We're going to say, all right, well, in that case, let's replace the g of x with the u. Let's call that something else. Let's call that u. Okay, so what am I calling u? Is I'm doing this. I'm calling this u. I'm replacing the inside function with the letter u. Okay, to make it easier. So if I do that, this now becomes u. This whole thing becomes u. So now it's actually just y equals to u to the power of 5. Okay? And so therefore, if it's u to the power of 5, that's just like writing that. And if I ask you to find the derivative just using chain rule, remember the chain rule is dy dx is equal to dy du, which we know, because this is y and this is u, so the derivative dy du is just bring the power down, 5u to the power of 5 minus 1. So it's 5u to the power of 4. Yeah? So that's dy du times, what did I say the chain rule was again? Dy du times du dx. This was the rule for the chain rule. So if this is the rule, I've already got dy du because I've just figured it out. Dy du is the derivative of u to the power 5, which is 5u to the power 4. So 5u to the power 4. However, du dx on the other hand, well, this is my u, and that's my x. I've got a relationship. It's the change of u and over the change in x. So if I asked you to find the derivative of this problem, du dx is just equal to, bring the 2 down, so 2 times 2, x to the power 2 minus 1. And then derivative of a constant, well, we know it's 0, so this gives you 4x to the power of 2 minus 1 is 1. So that just now becomes times 4x. Okay? So if you multiply those two together, you should get your answer, which is 20x u to the power of 4. But remember, this was a made up variable. U doesn't actually exist. I made it up. I made it up so that it works. You see, I made it up. I replaced the g of x with a u to make it easier for myself. So by doing that, I have to resubstitute what u was, and u was actually equal to 2x squared minus 3. So I'm going to write it, 2x squared minus 3 all to the power of 4. Voila! Chain rule completed. Okay? I'll do another one. I'll do another one with less mess. Okay, so straight to the problem. Let's do which one? Okay, I reckon G a lot of students will hate, right? Because you all hate fractions and negatives. You like whole numbers and you like positive values back to primary school. That's probably when your mathematics was really strong. Okay? So here we go, G. We're going to look at it, we're going to say, alright, that's x squared minus 1 on x squared, fraction, all to the power of negative 3, right? Nothing too hard here. Same thing again. You've got two functions. Okay, you've got an inside function and you've got an outside function. Now, I don't like the inside function because it makes it hard. So I'm going to call that a third variable. I'm going to replace that and call that a third variable. I'm going to call it, let's call it u. U equals to x squared minus, and I don't like the fraction. I'm going to rewrite. Remember, you can write that fraction. That's a positive power on the denominator. You can write it as negative 2. Okay, x to the power of negative 2 is the same thing as 1 on x squared. Yeah? Alright, so I've replaced it as u. So why did I do that? Because if this is my equation, I've now replaced it so that it becomes u to the power of negative 3, because I've replaced the inside. Okay, so there's no longer the x squared minus 1 on x squared. And if I ask you to find the power of the derivative for this, it's so easy. dy du, not dx, dy du is equal to, drop the power down, so it becomes negative 3 u to the power of negative 3 minus 1, power rule. Yeah? Whereas over here, derivative du dx is equal to, all power rules again, bring down the 2, so it becomes 2x, and then plus negative 2 times negative x to the power of negative 2 minus 1. I should write 2 minus 1 here, just so you don't get confused. Okay, so this becomes 2x, and then that's what? Negative 2 times the negative becomes positive 2, x to the power of negative 3. Okay? And that's your du dx, or you can write it as 2x plus, again, remember, don't flip this 2, because this is times. This is the same thing as writing 2 times 1 on x cubed, so it becomes 2 over x cubed. A lot of students flip the 2 as well. I don't understand that. It wasn't negative on the 2, it was a negative power on the x. Okay? Break it up. Don't speed it up for nothing. If you do it really fast and you get it wrong, it's pointless, right? So, now you got du dx. Chain rule. Well, the chain rule says if you want to find the derivative of dy dx, which is what this case is, it's got a y, it's got an x. You want to find the derivative of that function, it's equal to dy du times du dx. So in that case, dy du times du dx, well, I've got dy du as, I didn't simplify it, negative 3 u to the power of negative 4. Okay, so I've got negative 3 u to the power of negative 4 multiplied to, and we'll use brackets because they're together, 2x plus 2 over x cubed. Okay, and you got to replace that u, so it becomes negative 3 u. Remember, u was over here, that's u. U is x squared minus x to the power of negative 2, all to the power of negative 4. And that's being multiplied to 2x plus 2 on x cubed. Technically, up until here, your answer is correct. Okay? But how I'd like you to write it, though, okay, and this goes back to how good your fractions and indices are, and I'm a bit skeptical about this one now, but I'm going to do it anyway. So, remember, this is negative 3 times. Now, notice this is the power of negative 4. So you can write it as a positive power by writing 1 over this entire bracket with the power of 4. Okay, so I'm going to write it out. It's negative 3 times 1 over the entire bracket, x squared minus 1 on x squared. So I don't like that negative power, yeah? And that's to the power of 4. See, instead of it being a negative 4, I've now made it 1 over that, and it's positive power. Times, because remember this is times, and then you got 2x plus 2x on 3. So I'm going to write it together, 2x plus 2 over x cubed. Okay? Why did I do that? Is because these are all numerator values. That's a numerator, that's a numerator, that's a denominator. So if you put it together, it's negative 3, 2x plus 2 on x cubed, all over x squared minus 1 on x squared to the power 4. And if anything, that looks nicer than leaving your answer as this. But in year 12, at the end of year, you might be excused depending on the number of marks. If it's 2 marks, that, yeah, it just looks, you see, your textbooks, it's too crazy. It's not going to look like that in your exam. It's going to be much more straightforward. Okay? Yeah, it'll be much more straightforward. So the question is, do you even collect, you know, these fractions over here? Do you? But this, if anything, this looks nicer, more likely to get an answer in an exam than this one. Okay, you don't want to leave negative powers around. Okay, but depends on the number of marks. If the number of marks looks little enough, then yeah, sure, it's fine. Okay. All right. So now I'm gonna do an exam, past exam question. So you can see this is a past exam. I can't remember which one I picked. I just picked probably 2007 or 8. And I looked at the first question. First question was always a derivative question. So same thing. This is a chain rule. That's why I said it's bread and butter. You're going to be using it over and over. So here we go. 4 minus x, and same thing. This is the issue. This was the inside function. It's a composite function, right? You got a linear equation inside. So what you can do is you can say, what if I replace that with the letter u? U equals to 4 minus x. Because if I do that, then now y equals the root of, instead of 4 minus x, it is now root of u. But I know that root of u is the same thing as writing u to the power of half. So that means dy du, the derivative, is equal to half u, half minus 1 is negative half. Okay? Whereas over here, u equals to 4 minus x, so du dx must equal to, find the derivative of a constant, it's 0, and then derivative of negative x, remember there's a power of 1, so it becomes minus 1 x to the power of 1 minus 1, which actually just works out to be negative 1. Okay, so according to the chain rule says dy dx equals to dy du, which we have, dy du, times du dx. So really we're just saying this multiplied to negative 1. So if I do that, my answer is just equal to negative half u to the power of negative half. But you can't leave your answer with a u, okay? And if anything, negative half, remember, this is the same thing as writing negative 1 on 2 times, instead of having a negative power, remember I said you can write it as 1 over u to the power of half being positive. You see the difference? That was negative. I didn't want a negative. I write it as 1 over u to the power of the positive half. Why did I write it like that? Because this now becomes negative 1 over 2 times 1 over, and power of half is the same thing as root of u, which makes it now, I'm going to just move it over here, okay, makes it now equal to negative 1 on 2 times 1 over square root, what was u again? U was 4 minus x. And so your answer is negative 1 over 2. See, this looks nicer than leaving your answer as this with a negative power of half. Don't do that. This is the more preferred answer. Okay? And that was the chain rule. So I can do it again. I can do another past exam so you can see. Let's do another past exam question. Whoops. Here we go. Same drill as before. So it's a composite function. You've got an x to the power of 5, and within it you've got a quadratic equation. So what I'm going to do is I'm going to call that u. So 3x squared minus 5x. Why? Because this changes the equation to y equals, instead of the entire quadratic equation, it's just u to the power of 5. So that means dy du is equal to 5u to the power of 4. Whereas du dx, on the other hand, is just a derivative of this. So that brings down the 2, so that becomes 6x, and that becomes minus 5. So the answer to all of this is dy dx is equal to multiplying those two together, dy du times du dx. So if I write it out, it's just 5u to the power 4 times, and I'm going to use brackets so I don't make a mistake. So that's your dy du, and that's your du dx. Replace the u again, and so that becomes 3x squared minus 5x times 6x minus 5. Now what I would do, just in case, depending on, because it's an exam question, and notice it's question 1 every time, chain rule, product rule, those are your first questions for your exams back then. I don't know if they've changed the format now. But if I were to answer the question, I would probably take out a factor of x. So I'd always factorize it, simplify or factorize it to its simplest form. So by taking a factor of x out, I now get 5x bracket 3x minus 5 times 6x minus 5, and that is a more preferred answer. Okay, but depending on the number of marks, I mean, if it's 1 mark, then leave your answer here, that's fine. If it's 2 marks, I'd probably take my chances and write it like this. Okay, that's the chain rule. And obviously, the other exercise like log exponential sign is going to be heavily reliant on chain rule to make it harder. Okay, because we all know the derivative of log of x, for example, is 1 on x. So, in order to make this problem harder, they're going to give you questions like this. Log e of, I don't know, 3x squared minus 2. Okay, and that's a chain rule problem because it's a composite function. It is a quadratic within a log function. And then you use the chain rule. Same thing again. Okay, I think that's the end of my chain rule slide. Yes, it is. It is the end of my chain rule slide. So, please practice exercise 90. It's your bread and butter, and otherwise the other exercises won't make sense. Oh damn, I've got half an hour left. Okay, let's I'm gonna try to make another video and upload hopefully 3 videos before I go. Okay, I think that's more than enough for this week. I'm doubting that you guys are all gonna do 9B, C, F, and E. Okay, all in the one go. But do revise those skills, because on the Monday when I come back, I want to ensure that these basic skills are somewhat sort of there. Okay, so because I'm going to ask you guys randomly to solve problems, and if you tell me you can't do a power rule or chain rule, I'm going to be very upset. Okay, because this is your bread and butter, power rule and chain rule. You gotta know these two off the bat, and the others I want you to know it, but you know, some of us might have forgotten year 11 stuff already, so I can forgive, we can practice, but ideally all the basic skills from year 11 should be covered by Monday. Okay, and I'll be reiterating it again anyway. Alright, cool. On to exponential.